Greetings everyone, I am Jonathan Lee from SAKI Corporation. Today, I would like to introduce one of our software products, the QD Analyzer. In the field of electronic component mounting, the importance of quality control has been increasing year by year. As a result, the inspection process now requires the long-term storage of inspection results and judgment histories, leading to challenges such as increased data storage volume and delays in data processing speed. SAKI's proprietary QD Analyzer solves these challenges and significantly contributes to quality improvement, productivity enhancement, and cost reduction. The greatest feature of the QD Analyzer is its overwhelming data storage capacity. It is able to connect up to 100 pieces of equipment to a single server. By being able to do long-term accumulation of large amounts of data, including images, it is possible to acquire, store, and reference a wide variety of inspection data in real time. It can also help in tracking back defective boards as well as quickly identifying the cause. Customers who need these features to be able to store data for the long term will find this beneficial. Another important feature of the QD Analyzer is its astounding data processing speed. Even with a large capacity database, fast data processing and searching are possible. With SAKI's unique high-speed processing engine, large volumes of inspection data are analyzed instantly, and reports such as defect causes and line availability rates are displayed instantaneously. Now let us introduce the features of the QD Analyzer. First, the QDA dashboard. The dashboard not only enables real-time monitoring of the overall performance of the production line, but also allows the user to instantaneously view and grasp the equipment operation status and lot progress. So now, we'll explain how to view the dashboard. From the left, there's SPI, AOI, and AXI. You can see the real-time operational status of the equipment in the line. By clicking on Machine Detail, you can analyze the status of the machine. Here, you can see which board is currently being inspected, the hourly operational status, among others. For example, looking at the graph below, you can see that the machine has been in operation for the last 24 hours. With this feature, Site Manager can monitor the entire factory remotely, thereby reducing the burden of production management. Next, we will explain the Analytics feature. Component Analytics is useful in identifying the cause of defects in order to improve the quality of inspection. This function identifies trends and root causes in defective components using graphs and saved images. First, narrow down the time period you want to analyze and select the judgment type. For example, this graph shows the detected defects per day. Immediately, you can see the days with the high number of defects. If you want to see the defects in more detail, click on the graph. Defect images will be displayed, allowing you to identify defect trends. You can also click on the images to see the defects more clearly. For example, if there is an increasing amount of bridge defects, improvement countermeasures such as performing maintenance on the solder printing machine can be implemented efficiently. The next feature we would like to show is OEE Analytics, which helps in improving production efficiency. OEE stands for Overall Equipment Effectiveness, which is an indicator that comprehensively evaluates equipment efficiency. Overall equipment effectiveness can be quantified as operating time rate, by performance operating rate, by OK rate. By using OEE in QDA, the performance of the line can be understood at a glance and helps identify the causes of poor operating rates in the line. Let's take a look at this OEE Analytics report. While performance OEE and quality OEE exceeded 90%, which would indicate high production efficiency, the global OEE has a low percent due to availability OEE, which is the operating time falling below 50%. By clicking on Show Detail, we can see the amount of time that the machine was powered off, indicating that the device was mostly inactive, causing time loss. By identifying the cause of time loss revealed by OEE Analytics and improving bottlenecks, productivity can be increased. Lastly, I will explain the reports function. Let's start by looking at drill down reports. Drill down analyzes defect causes from various angles and helps identify the causes of defects. The graph in the upper left is the daily defect occurrence report. Not only can you identify days with high defect rates, but by clicking on the graph for a specific day if you want to investigate, you can analyze the number of defects occurring by the hour. Board top 10 indicates the boards with the most defects, while reference top 10 indicates the components with the most defects. Clicking on the graph reveals more detailed analysis. For example, let's click on the board with the highest number of defects in the board top 10 chart. Here, we can see the top NG reference components with the most defects and height as the most common defect type. Reports can be customized according to each person in charge. This report was for the factory manager. But if the scenario is changed to programmer, the report items will change accordingly. Scenarios can be edited or newly created, allowing you to add new optimized reports for each person in charge. Next, we'll explain Traceability report. Traceability analyzes which boards have what kind of defects. Instantaneous data processing and searching are completed for over 46,000 circuit board entries. If we search for a board number, for example, if we were to enter this barcode number, we can see the associated board data instantly. When you click on View Detail, a full image of the circuit board and defective areas are displayed below. With this, you can manage the history of defective boards, and if asked to report defective boards, proof can be provided quickly. Next, I will explain FPY report. FPY is used when checking the first pass yield rate. The horizontal axis represents the timeline, showing OK, NG, false call status by time. You can customize the timeline based on your preferred time unit. For example, on this specific hour, you can see that there are 141 OKs, 16 NGs, and the first pass yield rate is 89.8%. Finally, I will explain the parts comparison report. The parts comparison report makes it easy to pinpoint where defects are located on a circuit board. NG components are shown below and can also be checked with enlarged images. That concludes the introduction to the various functions of QDA. Since QDA allows data to be accessed from outside the factory, data from each factory can be sent to the main server for centralized management. In addition, the QD analyzer can also collect data from X-ray inspection devices. By using SPC that fully leverages SAKI's total lineup solution of SPI, AOI, AXI, improved productivity across the entire factory is ensured.